welcome to Mickey Techie. Let's learn and let's teach. I would like to thank my family for continuous support and encouragement to doing these kinds of technical videos. And I would like to thank my mentor, Professor Surendran from Government College of Technology, Coimbatore. And I would like to thank Almighty, my God, for making these kinds of videos and sharing the content to you all. Today's topic of interest is thermal stress. How the thermal stress is created in a material. We know that all the materials will expand and contract according to the temperature, change in temperature. Like that, if any body, if it is attached with another body or another constrained content, when the temperature is applied on the body, in nature, the body tend to expand or contract due to the temperature difference. Due to the expansion and contraction process, there is a stresses and strains are produced. So that the thermal stresses or the stresses induced in the body due to change in temperature. With this background, we know that the temperature thermal stress due to the temperature difference it will occurs. Okay. First of all, the basic formulas, we have a three basic formulas. One is thermal strain. Thermal strain E of T is equal to alpha into delta T. And thermal stress, we know that sigma T is equal to, we know that from the formula stress is directly proportional to strain, therefore stress is equal to Young's modulus into strain. Here the same thing is coming to picture. Alpha del T is the strain and whereas E is the Young's modulus of the material. Therefore the thermal stress sigma T is equal to alpha delta T into E. Next, change in length. We know that strain is equal to change in length by original length. Strain is equal to change in length by original length. Therefore, instead of E, we put delta L by L. Therefore, delta L by L is equal to alpha del T. Therefore, we need an change in length. We are interested in finding change in length delta L. Therefore, the denominator of L is going to in the right hand side and delta L is equal to alpha del T into L. Next, we are going to see some of the cases for the constrained body thermal stress. From this name constrained, if you see any of the question or any of the condition, if you see any constrained, there the strain is 0. Whenever the body is in constraint, the strain is 0, whereas stresses will create. So this is the our understanding. First case 1, if the temperature increases in a constrained body, what will happen? The temperature increases. We know that if it is a constrained body, strain is equal to 0, whereas stress is produced. In the case of increase in temperature, the compressive stress is produced. In case of decrease in temperature, there tensile stress is produced. If in the case of free body, you know that if let us say if we are free, not into any stress. If we are constrained, we have a stress. So with this background of just a simple understanding, a free body having zero stress. Yeah, whatever the temperature increases or decreases, the free body will have no stress or zero stress. If the temperature increases, tensile strain is developed, whereas stresses is zero, strain is developed. In the case of decrease in temperature, compressive strain is developed. We have yet another condition, thermal strain due to yield. If the ends are yield, if the body is subjected or it is supported by another body of another different material. If the temperature is applied anyhow, the another body or a supported body is also affected by means of a temperature difference. Therefore the ends can yield. So such that condition, the strain, thermal strain E is equal to alpha delta L minus delta divided by whole L. So total length, L is the total length, alpha is the coefficient of thermal expansion, delta T is the change in temperature difference, and L is the length, and delta here, delta is the yield. Okay, end yield, how much yield is done by the end supports. Next we know that thermal stress, anyhow stress is equal to strain into Young's modulus. Therefore the strain formula into Young's modulus, that is equal to stress sigma is equal to alpha delta L minus delta divided by L into whole into Young's modulus. Now I am going to discuss about coefficient of thermal expansion for different materials, which I have an idea. Okay, for this we know with the mnemonic code ABC is a supercritical words. The alphabets starting with ABC, these three words are very supercritical words, which means here the aluminum, brass, copper, which are having more coefficient of thermal expansion. For this remembrance, we need a mnemonic code like ABC, supercritical. Okay, let's discuss. Aluminium having a coefficient of thermal expansion of 23 into 10 power minus 6 per degree Celsius, whereas brass 21 into 10 power minus 6 per degree Celsius, and for copper 17.2 into 10 power minus 6 degree Celsius. For the steel and concrete 12 into 10 power minus 6 per degree Celsius. So, in order to remember that the first three materials, aluminum, brass, copper, are more in coefficient of thermal expansion. Because more coefficient of thermal expansion value, less coefficient of thermal expansion value, they will expand quickly. Okay, they can expand quickly, very faster they can expand. Okay, thank you for watching. Please share and subscribe the video. If you have any comments or any doubts, please let me know in the comment section, and I will put an at another video for your better clarity. Thank you.